Okay, this is Unit 2 Chemistry Section 2.2, Part 5. So this focus is going to be on bonding. Forming compounds. When two atoms get close together, their valence electrons interact. So that again is that outer shell of electrons. If the valence electrons can combine to form a low energy bond, a compound is formed. Each atom in the compound attempts to have the stable number of valence electrons, which is the same as the nearest noble gas. So basically, atoms will lose or gain electrons in order to have a full valence shell, which is identical to the nearest noble gas, which is what we saw in our sodium example on the last slide. It was trying to be like neon, which is its closest noble gas. Metals may lose electrons and nonmetals may gain electrons. So this is called an ionic bond. So a metal and a nonmetal together form an ionic bond, or atoms may share electrons, which would be considered a covalent bond, which is when two nonmetals bond. Okay, so it's important that you know the difference between those two things. So again, ionic bond between a metal and a nonmetal, and a covalent bond is between two nonmetals. So we're going to cover ionic bonds first and then get into covalent bonds after. So ionic bonds form when electrons have transferred from positive ions to negative ions. So electrons have moved. Covalent bonds form when electrons are shared between two nonmetals. Electrons stay with their atom but overlap with their shells. Okay, so this example up here, so you can see that the electrons of carbon, which are shown in blue, you have 4 of them, so these are just the valence electrons. And then hydrogen, which only has 1 electron, is sharing, so the shells are overlapping. So each hydrogen shares 1 electron, so it appears then as though hydrogen has 2, meaning a full shell like helium, and carbon has a full shell of 8, which would make it like neon. Ionic bonds are formed between positive ions and negative ions. Generally, this is a metal and a nonmetal ion. For example, if we look at lithium and oxygen forming an ionic bond to form the compound Li2O. This example has been drawn without the shells, so you can see that like these 2 electrons here are in the first shell and then there's 1 in the second shell. So this is representing the 3 electrons that lithium has. And then oxygen has a total of 8 electrons. So it has 2 in the first shell, and then it has the remaining 6 in the next shell. So what happens here is this one, referring to this 1 electron here of lithium, is going to be given to right there, kind of like that. So by this first lithium sharing its 1 electron, oxygen now has 7 valence electrons, but it needs 8 to be considered full. So because of that, we need a second lithium, which is shown here when it tells us we have 2 lithiums sharing electrons. So this lithium here's outer electron is going to be given to oxygen as well. So now each lithium has lost 1 electron, which we're symbolizing by this plus symbol. So again, remembering that for ions, we represent it with these square brackets and the charge to show that you didn't just forget to draw an electron. So for the O2 molecule, it has gained 2 electrons. Sorry, O2 minus, not O2. So we've got the -2 charge on it with the square brackets. And then the last lithium plus, again, it's lost 1 electron, giving it an overall positive charge. So the charges should balance out. So we have two positive charges and a -2 charge. So overall the charge is 0, which is what we want. So this is what makes up lithium 2 oxide. Here's another example of sodium chloride, just represented in traditional Bohr models, which we remember. This electron in the outermost shell of sodium, so its valence electron, is going to be transferred to chlorine, which has 7 valence electrons. By doing so, sodium becomes sodium plus, so the sodium cation, which has a full outer shell now because it's lost that 1 extra electron, and a chloride ion, which is the anion, which has 8 valence electrons. So it's gained 1 to have a full shell. So same idea, just a different way of representing it. For this example, again, if we were drawing the Bohr models, we would draw them like this, but they should have those square brackets around them. Okay. It's also important to know that ionic bonds don't just form pairs, so we don't just have one sodium and one chloride ion. They actually form a crystal lattice structure. So you can see the chlorines represented in green here, and the sodium's represented in gray. And like charges, if you remember, repel, whereas opposite charges attract. So this one chlorine ion here would attract this one, this one, this one, and this one. And it does that with multiple ions, forming a crystalline structure. So this is a little bit different than a covalent compound. Okay, so practice drawing Bohr models for each of the following ionic compounds. So what I'm going to do is walk you through how to do one of these, and then the remaining 2 will be for you. Notice that one of these is given as a formula rather than a name, but the steps for it are still the same. I'm going to go through and do calcium chloride because it's the most annoying of the bunch. To save space, I'm just going to use the symbol for the Bohr model. So calcium is atomic number 20, which means it has 20 protons. And chloride is chlorine, which is atomic number 17. So to start off with, we're going to do our calcium molecule. So I'm going to write my symbol, Ca, my nucleus. My first ring holds 2. My second ring holds 8, so 2, 4, 6, 8. So we're up to 10. The next ring can hold another 8. 2, 4, 6, and 8. So we're now at 18. Calcium is going to give up its 2 extra valence electrons in order to have that full outer shell. So for our chloride ion then, before we do anything, it is Cl. I've got first ring has 2, second ring holds 8, third ring, so we're at 10 again, 1, 2, 3, 4, 5, 6, 7. So notice that I've left that 1 electron unpaired, and essentially what that is for is because calcium is going to donate one of those 2 valence electrons to chlorine. Now we still have 1 electron unaccounted for, so we need a second chlorine to pick up that extra electron. So again, I'm going to do another chlorine molecule. So Cl, same thing as the first one. So again, we're at 10. Okay, and then again, it's going to pick up that extra electron that calcium has in its valence shell. So now all molecules have full valence shells, so they're all happy. And the only thing we're missing here is our square brackets to symbolize that it's an ion. So calcium has lost 2 electrons, meaning it's now 2+. Chlorine, or the chloride ion, has gained an electron, so it has a -1 charge. And then I'll squeeze in the second bracket here. And again, this chlorine has a -1 charge as well. Remember that the charges need to balance, so we've got +2 and 2 -1 charges, so that's going to equal out to an overall charge of 0 for the compound. Okay, so try the other two. I will post the answers for these. Okay, so we're now going to move on to covalent bonds. So that last example was ionic bonds, now on to covalent. So covalent bonds are formed between 2 or more nonmetals, and the electrons are shared between atoms. So again, here we've got an example of hydrogen and fluorine. If you look, these are both on the right-hand side of the periodic table, so they are both nonmetals. Hydrogen has 1 valence electron, and you can see that fluorine has, so it's got 7, so it's basically this electron here is unpaired. Instead of passing it off, what happens is this electron is going to be shared with fluorine, and this electron from fluorine is going to be shared with hydrogen, creating this bond here. On the bottom, it's symbolized as a Bohr model. So same thing here. You can see that hydrogen has 1 valence electron and chlorine has 7. And then it forms this bond that's shared. So the electron isn't being passed, it's simply just being shared with the other ion. Okay, so let's work through an example of this. So these ones, I apologize, are a little bit annoying to draw, but we only have 2 examples here. I will do the first one and you will do the second one. So we're working off the formula here for carbon dioxide. Di means 2, and we can see that there are 2 oxygens. Remember again that we're not passing or transferring electrons, we're sharing electrons. So we're going to draw the Bohr models as if they're connected to one another. You only need square brackets for ionic compounds, not covalent, because the electrons are being shared, not transferred again. Okay, so let's start off here. Okay, so what I'm going to do is I'm going to draw these as a step-by-step process. If you see the connections with them, you can just go right to the kind of final product for this. But if it helps, do it in a step-by-step manner, and then that way you can kind of see where the electrons are going when they're being shared. Okay, so let's start off by drawing our carbon and 2 oxygens. So for ease, I'm just going to draw carbon in the middle and then the 2 oxygens on either side. So I've got carbon, its nucleus, and it has 6 total, an atomic number of 6, which means it has 6 protons, and therefore in atom form it has 6 electrons. So 2 electrons in the first shell, and then the remaining 4, sorry, this is a bit messy, are in the outer shell. So if you count, you have a total of 6 there. Oxygen has an atomic number of 8, meaning it has 8 electrons in its atom form. So I'm going to draw an O. I've got Oops, sorry, this is the nucleus, not the first shell. First shell. So always have a nucleus as well as a first shell. Okay, so 2. And then it's got 6 electrons left over. So 2, 3, 4, 8. So like that. And then this tells us we have 2 oxygens. So we're going to draw a second one. And basically I'm adding these things together, if you want to think of it like math. So O, nucleus, 2 in the first shell, and then 1, 2, 3, 4, 5, 6. Okay. So what we want to look at is basically how carbon has 4 unpaired electrons and each oxygen has 2 unpaired electrons. And remembering that these are going to be shared. So I'm going to do this in, I wish I had more colors than this. I'll do it in purple and hopefully it'll show up. So we want to think of our electrons as pairing together for where they'll be shared. So these 2 will pair together. These 2 here are going to pair together. And then we still have 2 more electrons unpaired. So I'm going to pair up these 2 lone electrons and these 2 here. So I'm going to redraw this out for you. So again, you don't have to show it in 2 steps like this. You can just show the final product, but I wanted to give you a visual. So again, we've got our carbon in the middle. I'm just going to cross this out for now, just so you'll do. But I don't want you to get confused and think that I'm drawing it underneath. So this is the continuation of carbon dioxide. So carbon, nucleus, first ring has 2, that's exactly the same. Second ring now has I'm going to draw its 2 electrons so it's easier to show them bonded together. Okay, and then I'm going to draw in my oxygen close together so the rings will overlap. So I've got my O nucleus, first ring, and then I'm going to draw my second ring just to connect nicely here. So with those carbon electrons, I'm going to draw in my oxygen paired electrons. And I'm just going to make the red ones a little bit more clear here. So there we go. So you can see now they're sharing those electrons. And then we want to fill in the remaining ones that were already paired up with themselves in oxygen. Okay, so like this. Okay, and then we're going to do the same with the second oxygen. So I've got my nucleus. My first shell contains 2 electrons. And then we want our second shell to connect with those. Sorry, it's a little bit awkward to draw. And we're going to pair our electrons. And then we'll fill in the remaining. So now what we want to do is just basically go through and count and make sure that each element in the compound has 8 valence electrons. So if I look at oxygen, for example, it's got the 2 blues, so 4. And then it's got the 1, 2, 3, 4 in the shared, so a total of 8. Carbons are all shared with oxygen, so that's 2, 4, 6, 8. And then again, the oxygen, the pair of shared, so 2, 4, and then 6-8 for its other 2 electrons. Okay, so I would like you to pause here and do the same thing for ammonia. Again, you don't have to do the step-by-step, you can just go to the final form. And actually, you do not need to pause because this is the end of this section. So you can move on to the remainder of your practice. Sorry, just ignore the eraser here. I'm just gonna get rid of that so you can see. I'll draw an arrow. This is my work, final covalent. Okay, so you can move on to the next video based on the schedule for today.